Dear students, in this video I explain Unit 5 TTL Logic family. The logic family means there are various approaches used to produce the different types of digital integrated circuits. Each such fundamental approach is called as a logic family. An integrated circuit or IC, sometimes called as a chip or microchip, is a semiconductor wafer on which thousands or millions of resistors, capacitors, and the transistors are fabricated. That is nothing but integrated circuit IC. An IC can function as an amplifier or oscillator or timer or counter, computer memory or microprocessor. So the ICs can functions as these all are the functions of ICs based on the developed IC. The digital ICs operates with binary signals and are constructed with ICs. The digital ICs can be classified into two categories. First one is the MOS family. It includes the following metal oxide semiconductor field effect transistor. MOSFET means metal oxide semiconductor field effect transistors. The P-channel MOSFET, N-channel MOSFET, complementary MOSFET, C MOSFET. This is the different types of MOSFET families. Bipolar logic families. These ICs can be classified as saturated and non-saturated logic families. So, saturated logic families consist of resistor transistor logic RTL, resistor capacitor transistor logic RCTL, diode transistor logic DTL, high threshold logic HTL, transistor logic TTL, integrated injection logic I square L logic, I square L logic. These are the saturated logic family different types. Non-saturated logic family consists of Schottky TTL, emitter coupled logic ECL family or ECL logic. So these are the bipolar logic family different types, saturated logic and non-saturated logic. The characteristics of digital ICs are speed of operation, fan in, fan out, noise emittivity, propagation delay, power dissipation. These all are the characteristics of digital ICs. So the characteristics of digital ICs, the first one is also known as so fan out, also known as loading factor, defined as the maximum number of logic inputs that an output can be derived reliably. So the fan out means simply we can say that the number of outputs are connected to the logic family or the logic circuit is called as fan out. So a logic circuit that is specified to have 10 fan out can be driven 10 logic inputs. So that the number of outputs are connected to the logic family or the logic circuit is called as fan out. Next one is fan in. It is the number of inputs that can be connected to the input of the logic gate. So that the number of inputs are connected to the logic gate is called as fan in. The number of outputs connected to the logic gate is nothing but fan out. Next one is power dissipation. The power dissipation is a parameter that represents the amount of power needed by the gate. The amount of power needed by the gate is represents the power dissipation. It can be calculated as the power dissipation is the product of VCC into ICC, where VCC is nothing but supply voltage, ICC is nothing but the current that is drawn by the circuit. The multiplication of these two are nothing but power dissipation. The current the current drain from the power supply depends on the logic state of the gate. The average current is ICC average is equal to ICCH plus ICCL divided by 2, where ICCH is nothing but the current that is drawn from the power supply when the output of the gate is in the high voltage level. ICCL means the current that is drawn from the power supply when the output of the gate is in low voltage level. So these are the representations, and the power dissipation is nothing but product of this VCC and ICC. Next one is propagation delay. The propagation delay of the gate is the average transition delay time for the single for the signal to propagation from input to the output when the binary signal changes in the value. That means, so when we are changing the input, the required time to produce the output is nothing but propagation delay. So that is nothing but propagation delay. Next one is noise margin. First one is the noise. Noise is the term used to denote an understanding undesired signal that is superimposed upon the normal operated signal. So the unwanted signals are nothing but simply the unwanted signals are nothing but noise. The noise margin. Noise margin is the maximum noise voltage added to an input signal of the digital circuit that does not causes an undesirable change in the circuit output is nothing but noise margin. Next one is figure of merit. It is the product of speed expressed as the propagation delay time and the power dissipation is nothing but figure of merit. So the TTL stands for transistor logic. It is the logic family implemented with bipolar process technology that combines or integrated NPN transistors, PN junction diodes, and diffused resistors in a single monolithic structure to get the desired logic family. So that the TTL logic family consists of transistors and PN junction diodes. So combined together, and some resistors also included here. The combination of these three elements is nothing but transistor logic family. The NAND gate is the basic building blocks of this logic family. So different subfamilies in these logic families include stands TTL, low power TTL, high power TTL, low power short key TTL, advanced low power short key TTL, advanced short key TTL, and fast TTL. These are the different logic family inside this TTL logic family. The The original basic TTL gate was a slight improved over a TTL logic gate. So TTL means diode transistor logic. The TTL logic family was introduced from the DTL logic family, where the DTL is nothing but diode transistor logic. From this diode transistor logic, we can modify it, or we can retrieve this TTL logic family, transistor logic. Before this TTL logic family, the family is DTL, diode transistor logic. So from diode transistor logic, we can derive the next logic family, that is TTL, transistor logic. TTL gates have three different types of output configurations. The first one is open collector output, second one is totem pole output, third one is three-state or tri-state output. These are the three different circuits in TTL logic family. So one is open collector output, second one is totem pole output, third one is three-state or tri-state output. These are the three circuits output configurations in the TTL logic family. Then this TTL logic families was derived from the DTL logic family, diode transistor logic family. In diode transistor logic family, so the diodes are replaced with the transistor NPN transistors, then the family is called as TTL logic family. So these three output circuits are explained in the next video.